Everything that we've done so far has been linear. So these are linear. What do you notice is being done with x? You're multiplying by x. What makes an exponential? What is x doing here? Am I multiplying by x in that y is equal to 2 times by 1.2 to the... Am I multiplying by x? Am I raising it to the power of x?
Raising it to the power.
X is a power now. Okay? So here you can see the variable x is a power. So an exponential function is one where the variable x is a power or an exponent. The first notes that you'd want to get is this in year 11, also year 12. This is what I'm going to teach the year 12s straight up anyway when they do exponentials. In year 11, we look at exponential functions in this form. Y is equal to a times by b to the power of x. Y is the value of the y variable. X is the value of the x variable. Now, you're used to this. Y is equal to mx plus c. Do you remember what the m stood for in linear? The gradient, and c was the y-intercept. Here it's different. A is the y-intercept, and there is no gradient. We call b the multiplier. Can you just get that first box, please? Pretty quick lesson, so you'll be able to chat pretty soon.
Yeah, go for it. Perfect stuff to use in rather than yeah.
Y is the value of the y, x is the value of x, a is the y-intercept, it's where y starts. B is the multiplier, it's what y is multiplied by each time x increases by 1. You'll see that when we fill in the table. Right, the first thing to do is practice actually using the function here. So the only example we're running through is this. Look at the function, y is equal to 5 times by 2 to the power of x. Why you eat? Is that food? It looks like snacks to me. You want to gaslight me? I'm familiar with snacks. Well, not as much anymore. I'm on healthy snacks now. You just need to get good at using the function so you can graph eventually. But fill in the table below for this function. How am I going to fill in that table? I want to know what y is when x is 0. So 5 times by 2 to the power of nothing. What is any number to the power of 0? Does anyone remember? 1. Well done.
Oh, wait, 1.
So it's going to be 5 times by 1. So the first number is going to be 5. Do the same thing for 1. Y is equal to 5 times by 2 to the power of 1. What is anything to the power of 1? Itself. So it's going to be 5 times by 2. So the next one is going to be 10. Y is equal to 5 times by 2 squared. Girls, can you quickly sit down because there's people behind you? 2 squared is going to be 4. So it's going to be 5 times 4, which is 20. So hopefully you can see, if I was graphing this table, that is not going to be a straight line. It's going to go up, and then it's going to go up even more, and it's going to go up even more, because the first jump, what did the y variable do the first jump? It went up by 5. The next jump, it went up by 10. And so the last one, what do you reckon is going to go up by 5 times by 2 to the power of 3? 5 times by 8, 40. So copy and complete the following statement, and this is confirming what's happening with the multiplier. Remember, b is the multiplier. It is what y is multiplied by each time x increases by 1. Is y doubling each time? It went from 5, now it went to 10, now it went to 20, now it went to 40. Because why? Because the multiplier is 2. If I multiply something by 2, I double it. Okay? So as x increases by 1, y is being multiplied by 2. That's your little intro to exponential functions. We're no longer talking about straight lines. We're talking about curved ones. They are more important and more realistic for real life. There's not much stuff in real life that goes up in a straight line. You just did compound interest. Compound interest increases in the curved line. It doesn't go up straight. So your only exercises today is going to be 1, 3, 4, and 5 of 13b.